Good afternoon, everyone, and welcome to the webinar today, Technology for Controlling Weeds in Vegetable Production. My name's Carl Larson from RMCG. We've got a number of people joining from around the country and overseas. So there's about 60 of us due to join in. So thanks very much for your time. We hope it's really interesting. Before we do make a start, just quickly, a little bit of an overview of the functionality of the GoToWebinar. If this is the first time you've joined one of these sessions, you'll see on the control panel, there's a number of items there that you can see the attendees and who else is online, and your audio controls as well. The main thing I wanted to point out on the side there is that there's a little section there to type in questions. So at any stage during the webinar, if you do have a question, please type it in there and it comes straight through to me and I can put that to one of our presenters in the Q&A session. So we've got a really great lineup of speakers today and covering three main areas. I guess the driver here is that Mark Hinderegger from AHR and myself, who's also on the line, really jumped into this issue of weed technology because of a number of areas. That increased push from a resistance management point of view and also efficiency of inputs has really led to a lot of, I guess, innovation and development in this area. So today we're looking at firstly steam saturation, developing of chemical-free weed management, also jumping into some technology called WEEDit and Recapture, which you may be familiar with. We'll find out a bit more about what that is and how it works. And we're going to round out the presenter sessions with looking at the use of radio frequency for precision implement guidance in row crops as well. You'll then have a good chunk of time at the end there around Q&A and engaging with each of the panel presenters, which is fantastic. But I just wanted to mention too, the webinar is being delivered today under the Soil Wealth and ICP project. And essentially that's all about getting research on soil management and plant health out onto farm. We're in our second phase now from 2017 to 2022. And it's a national project funded by Hort Innovation. So really looking to respond to industry needs around those two main areas. There's a number of demo sites in each of the main growing regions around the country, and we run a number of events like today's webinar, but also face-to-face masterclasses and farm walks, as well as develop some resources which you've got in your handout panel in the go-to window there as well, which you can download and take away with you today. So before we do get started and I introduce our first speaker, I just wanted to launch a very quick poll on what everyone's level of understanding or experience is in technology for controlling weeds in veggie production. So you'll see there's a quick little poll there to answer lots, a bit, not much or none. That just gives us an idea of where everyone's up to and how to pitch some of those key messages for our presenters. So I can see we've got about 3/4 of us have voted, 80%. I might just close that poll now and share the results back with you. So interestingly, we've got a big cohort with a bit, so about 60% of us with a bit, 30% not much, and a small cohort of us up the top with lots. So thanks very much for that. I'm just getting a little bit of background noise from, I think, one of our presenters. So we'll just be conscious if we're not talking, if I could ask you just to mute your phone and microphone. We've got each of our presenters joining on phone because of remote locations today, but that just cuts out some of the background noise and makes it easier to hear. Okay, so our first speaker today, Jeremy Weiner from Weedtechnics, he's going to talk to us about the Satusteam technology. And we were actually talking earlier about the title of the presentation, Weed Killer Safe Enough to Drink. So I think that might prompt a few either grimaces or laughs or tongue-in-cheek, so that's fantastic. Jeremy, where are you joining us from in New South today? Jeremy, have I got you there?
That's Jeremy.
He just
Chop, chop.
he just told him to mute him. Jeremy's trying to figure out how to unmute his phone.
And Jeremy, can you hear us? We can't actually hear you. You might be still muted. No. So, Jeremy, are you on the line there? That's all right. Look, what we might do while we're waiting for Jeremy just to come back on the line, Dave, are you happy to jump in and talk us through WEEDit and Recapture? Is that okay? Can you hear us?
Yeah, not a problem.
Yeah, excellent. So we've got your profile shot up on the screen ready to go. So we might go with you first and then hand back to Jeremy later on. Jeremy, Dave, where are you joining us from this morning? What can you say?
So today I'm at the Parks Regional Show, having to hear with my dealer and talking about and displaying WEEDit technology. I've also a little bit later got a presentation to do to the local community here on WEEDit as well.
Yeah, sensing for
Fantastic. So out in the field. Dave, I'll hand over to you to run through your presentation, and really interested to know more about WEEDit and Recapture. So over to you.
What I'll start on is possibly the WEEDit, and then I can just the last few minutes a bit of a talk on Recapture. Mainly WEEDit, as everybody has probably been reading over the last 5 years. WEEDit is a camera detection sprayer. It's more for spraying green on brown at the present stage. So basically, currently, if we have fallow country, if we pulled our vegetables out, we've got fallow there, we're getting weeds coming up. We normally either go along with a plough and plough it all up and put dust and plenty of diesel into the air, or we turn around and go and blanket spray it with some very high rates of broadleaf weeds or so forth. What WEEDit does is you still have that. You have a camera rolling along the front of the boom. It's mounted to the boom. In that camera, there is 5 cameras looking down to the plant. The camera picks up the chlorophyll in the plant and then talks to a nozzle out the back and only fires the nozzle to turn around and say, okay, we're coming along, see a green weed, I'm going to spray that green weed. That is the simplicity of WEEDit. Such a simple technology. What it basically cuts down is 95 to 98% chemical use. We're also reducing the amount of water that we're having to use. And these days in drier times, water is becoming a very scarce commodity. So the less amount of water we have to punch out, the better. So with the beauty of WEEDit is, yes, it can be retrofitted to a conventional boom spray, as in the way of linkage. Units in that regard. So basically the WEEDit's going to come along where we can start giving our normal glyphosates, our basters a bit of a rest, and we can start going into different chemistry. So we can start getting on top of our resistant weeds that we're having issues with in our crops. So that's the beauty of WEEDit. It's such a simple system. So the way it works is the camera out the front, which has 5 cameras in it, it's going down, it's reading a red laser beam, it's looking into that red laser beam, and WEEDit actually looks for chlorophyll, the actual active chlorophyll in the plant. So if it picks up the active chlorophyll, it then turns around and sends a message to a solenoid activating a nozzle. With a WEEDit camera, they are mounted a metre apart along the boom. One camera operates 5 solenoids, nozzle solenoids. If it turns around and sees a weed in the left-hand side of that 1 metre, it only fires 1 nozzle. The nozzle that we run on a WEEDit is a 40-degree O3 even fan spray quality. Even fan. It produces a coarse spray quality at the current stage. We have a new nozzle that's out there for anybody that uses 2,4-D. As we all know, from the 1st of October to the 15th of April, we need to use an extremely coarse spray quality. WEEDit has a permit for use with 2,4-D, and we have a nozzle that will fit into that to produce a 40-degree O3 coarse spray, extremely coarse spray quality. So it will then only fire onto the ground. When it hits the ground, we are turning on 200 mils before the plant and 200 mils after the plant. We're applying it 20 centimetres wide, and the dose travelling at 15 kilometres an hour at the present stage is applying 100 litres a hectare of water to that. When you go working with a WEEDit, your tank is a lot smaller. We don't need to be using large volumes, like we don't need to go and load up a 1,000 litre tank. 1,000 litre tank with a WEEDit in place is going to last you around about 14 to 16 hours of spraying without hopping out of the cab. So the beauty is when we hop into the vegetable industry, and Carl, if you want to maybe put up the picture of the linkage with the little WEEDit burn that I sent you through this morning.
Yeah, not a problem. Yep, we've got that up now.
Got that up now. So
yep.
That is what a WEEDit looks like mounted to a little linkage. That's a 300 litre linkage with left and right. That unit is going to vineyards. So we're doing weed control. The wings on the side are adjustable, so we can adjust them up. And basically, we're reading green on green. We are planning on doing, for those that have had vineyards, also looking at doing a desuckering system with this machine as well. So there's a lot of opportunities out there. But where the best part of WEEDit is, especially getting into our vegetables, our vineyards, our blueberries and raspberries, a lot of those row crops, we can start turning around and looking at, there's a lot of people out there that are organic. We can run organic products through this WEEDit. That is the best part of it. So I've got people applying Slasher through this system, which is an organic glyphosate. So we can do that. We can run Basta through it. We can run. I've got other crowds that use WEEDit in a different way, not so much for a weedicide actually going over the top of their crop. Because it picks up chlorophyll, it can actually spray. So if you're wanting to put out a calcium over the top of your plant, you can actually go across the top, spray. It sees nothing, it won't spray. So that is the beauty of WEEDit. Such a simple technology. It has a controller in the cabin. It sits in there. You mix your brew into your tank, turn your pump on, put your tractor into gear, turn your controller on and drive. It automatically, it's got a speed calibration. So it understands that. It understands auto calibrates with light. So there's no, you're not having to stop and recalibrate to red or black or grey soils or nighttime or daytime. It auto calibrates on its own. It's a very smart system. That's the beauty of WEEDit. There's plenty of them around. There are 10,000 units of WEEDit operating in Australia today, and that's over the last 5 years. We have registered dealers throughout Australia that you're able to come and see these machines. We also have demonstration units. The little linkage WEEDit you see there at the moment has been manufactured by a dealer in Parks that is pushing it into vineyards. We're actually off to a vineyard tomorrow in the Orange region to set that up and get into it. Carl, if you want to maybe put up there's a water sensitive strip showing some droplets.
Yeah, not a problem, Dave. That's up on the screen now. Yeah.
Yep. So that'll basically show that's the spray quality. This is in a blueberry farm, Costa Blueberries at Clarindi, up near Coffs Harbour, Woolgoolga. They were using up around $1 million a year chemical bill to spray their 40 odd hectares of rows in their blueberries. By going to a WEEDit, we've been able to reduce that chemical bill back to $600,000 in a 12-month period. So massive savings. Instead of going through and just blanket spraying, it'll go through, it'll pick up the green. It's quite low. You can see the water droplets. You can see how close in we can get. And if you want to show maybe the next photo, Carl, which is the little red tank and showing a camera with a light.
Yep, that's up there.
So that there is a unit that they are using. That is a 30 litre, 12 volt sprayer with a little boom with a WEEDit on it going out. So that little unit there, sitting there at about $30,000. That's a lot of people will look and go, oh, that's an expensive system. But when you can reduce your chemical bill going out, the amount of we can get on top of residual weeds, so it's a much better system and quickly paid off. That little 30 litre tank spraying up and down those leg rows of all of those tunnels. That little 30 litre tank is now lasting them 4 to 5 hours, whereas before they used to have 6 or 7 people walking through there with knapsacks trying to spray. So it's a much better control. So that probably takes off WEEDit. It can be adapted to any system, can fit into any crop scenario. So if anybody would like to know more information, Carl has more information. He's got my email address, so anyone can follow up in that regard. Just now touched onto recapture for the vineyard sector. Croplands have been prototyping for the last 12 months a recapture system. There's a lot of information out there. The recapture the quantum Croplands have done has gone on to our Quantum Mist, which is the number 1 vineyard sprayer, as everyone knows, the best coverage in the world. So basically, the recapture's gone on to the Quantum. It's an adaptation that you can turn around and put on and take off. So in the early season, we got bud burst. We need to stop that off-target spray. Recapture can go on. It will basically, if you're talking of an over-row combination, there's going to be a shroud on the back side of your fans on the outer arm, and there's also one, as we call the bus shelter, which sits on the left-hand side on the tank. The spray going through the canopy will basically, what comes through and over the top is going to get caught in this screen, will drop down to a trough at the bottom. That is then pumped over, back through a filter and back into the main tank, and then punched out again. In recapture, at the moment, they're talking 50 to 60% recapture. And that seems to be the best of what's happening around the world with anybody that's using a recapture system. Best part with the Croplands recapture system is, as our canopy grows, we then turn around and say, hey, okay, we now need to get into a higher dose. We need to get a better coverage happening in here. We need to increase our air. We can actually take our recapture screens off, and we've got our big guns there. So you're not having to have 2 sprayers to go out. You can actually turn around, buy a Croplands recapture and go for it. This year we've got some prototypes still running in the field. Devil's Corner in Tasmania is using one of them. We've also got a couple of others running in New Zealand, and also some on the mainland of Australia. This year's prototyping, we're going out finding out really what we want, what our vineyard's wanting. Next year is going to be a major release of the recapture machine with new screens, a lot of new functionality, so we can actually control our left-hand hydraulically driven fans, giving a different air to the right-hand side. So if we're going into windier conditions, we'll actually be able to increase air speed on the one facing the wind and reduce the air speed of the one that's actually with the wind. So there's a lot of new advancements coming in the recapture. So keep an eye out for it. You'll see plenty of marketing coming out about it, and we are looking at doing demonstrations throughout Australia into vineyards and also throughout New Zealand. So that probably pretty well covers the cropland side of recapture and also WEEDit. I hope that's been enough there, Carl.
Yeah, fantastic. Thanks for that, Dave. Really great intro and overview of both those systems. We've had a couple of questions come through, but what I might do in the interest of time, just hold those over to the Q&A session. And Dave, if you could just hang on the line there until we get to that, that'd be fantastic. So thanks for that. Now, I'm just going to try and get Jeremy back on the line. Jeremy's
back on the line.
Fantastic. Thanks.
Can you hear me?
We can hear you. Yeah, I think we've just had a little bit of a connection issue early on, but that's all part of the technology and joining remotely. So after introducing what I thought was a pretty edgy topic title, we got radio silence, but we're back on. So Jeremy, what I can do now is share your presentation and go through your slides. And where are you joining us from today, and what can you see? I understand you're out in the paddock as well.
I'm in a park, car park in a park in Morpeth, just outside of Maitland in New South Wales. There's a few ducks underneath a tree, and looking out at some lovely paperbarks.
Fantastic. Well, thanks very much, Jeremy, and I'll hand over to you now to give us a bit of an overview of Satusteam and what it's all about.
Yeah, thank you very much. And this is a great opportunity. And I was listening into the really innovative technologies of WEEDit, and it's great that we continue to get more and more alternatives. And Satusteam is really an evolution of thermal weed control, of hydrothermal weed control, which is wet and hot. And I'll just go into a little bit, because my background in this really goes back to about 1996, and we developed our first steam really for application in the urban environment, in controlling weeds in cracks and crevices, in footpaths, curbs and gutters, and in well-maintained garden beds in parks and gardens. For Leichhardt Municipal Council at the time, which was probably the first council in the world to go non-chemical by council vote, they restricted or eliminated the use of herbicides for the control of weeds in their footpaths and parks. So at the time there was a hot water technology that we had to look at, and some people listening in may have been around in those days to see that system. It was really voluminous in the amount of water that it used. It uses a continuous flow hot water heat exchanger, very similar to what we use still, but using a lot more water than we were doing. It was using about 15 litres a minute, but it was heating it to a temperature of about 130 to 140 at the boiler. But by the time it left the boiler and ran down the delivery hose, it was boiling in that delivery hose as depressurized, and by the time it was delivered to the weed, it was being delivered at probably between 90 and 95 degrees. So there was a lot of water running down the street, and you can cook weeds slowly at any temperature above 58 degrees. The closer you get to 100 degrees, the more effective and the faster it becomes. So they were really cooking weeds slowly. So it was a really inefficient heating process. It was and very voluminous. So we went about making a steamer, thinking that was going to be the answer, not really understanding the process of thermal weed control at the time. We went about making a steamer using very small boiler and an LPG flame, and we were heating 15 litres of water an hour as opposed to 15 litres of water a minute. But in order to kill a weed with that, we were needing to hold it over the weed for about 10 seconds. And so that was never going to fly, although we did win a contract with it and had to resort to really mechanical weed removal rather than using the steamer. But I knew that somewhere in between the hot water and the steam idea was a solution. And what we sort of worked out was that by having a restrictor nozzle at the end of the applicator, we could maintain the pressure through the line from the boiler. And by maintaining the pressure of the water, we kept the boiling point way above the temperature that we were heating it to. So we were heating it to about 120, but it wasn't physically boiling because of the increased pressure. And it was only after it passed through that restrictor nozzle where it expanded into saturated steam. Now that was coming out at the same pressure that we were pressurizing it. So the first attempt that we did was really high pressure. It was creating the saturated steam, but it was also coming out as a blast, and it was moving the mulch. It was sort of compacting the soil, it was displacing the soil, it was blasting back, but it was certainly coming out at temperature. But from a horticultural point of view, we didn't want it to compact the soil or displace the mulch because it just wasn't going to work for us in the urban environment. So we expanded that water into a chamber. So from the restrictor nozzle, it went into a small chamber where that saturated steam could expand, but then coalesce back into a mixture of saturated steam and boiling water that was applied at the weed without pressure, therefore saturating the weed at boiling point. So if we can move to we can probably flick through a couple of slides. I've spoken about thermal methods, but if we can maybe flick down to the third slide, which was the proximity of the temperature, the saturation and proximity gave us thermal shock right at the weed. And thermal shock is delivered at about 100 degrees, 99 to 100 degrees, is way more destructive on plant cells and on the chlorophyll parts of the plant and heating slowly at lower temperatures. So if you can move to the fourth slide, as part of so what we called that mixture of saturated steam and boiling water was Satusteam, because it really describes the unique nature of the nozzle system and the process of how we create the Satusteam, which is the liquid that's applied to the weed to explode it. What we also worked out was that the ideal amount of water to apply and how far that could spread before it became ineffective. And so we really work in units of about 50 centimetres wide. And so our 5 litre delivery can heat or can treat weeds up to 50 centimetres wide, and anything narrower than that. The narrower it is, the more concentrated it becomes. And so from that, we're then able to develop a wider range of applicator heads. So these days we have a standard range of applicator heads that are used with our handheld applicators, which are obviously very popular with contractors and municipalities for use in those footpaths and around playgrounds, etc. But there are also a range of applicator heads that are used for use in intensive horticulture. So we have, and they basically increase in increments of sort of 50 centimetres. Our widest applicator heads at the moment are about 120 centimetres wide, and so they'll have 2 to 3 nozzles inside of them, and they're used underneath orchard trees, underneath the canopy of orchard trees, or for treating wider rows of prepared vegetable beds before either planting or just before the emergence of, say, carrot seedlings at day 19, when we've got the seed germination of the weed bed, of the weed seed, just before emergence of the carrot seedlings. And because we're using saturated steam that's depressurized, we don't get penetration into the soil. So one of the advantages of being able to use this technique is that it can be used in blueberries and before carrots come through, or before carrot emergence, without penetrating the soil, and of course in orchard trees without damaging the root structure or the roots or the rhizosphere or any of the complex ecosystem of the soil. Of course, we're only getting penetration 2 to 3 millimetres into the soil. One of the disadvantages of that process is that we're not getting down into the root system of the weeds. So we refer to the management technique as vegetation management. So we're controlling the weeds at the right time of year to benefit the desirable vegetation, whatever that may be that we are treating, whether it be intensive horticulture or in an ornamental landscape. So it's about vegetation management, and in some cases, depending upon whether the weed that we're treating, whether it's got a a complex and developed and mature root structure, those types of weeds will take more applications to wear out than weeds that have a very shallow root structure. So typically, very shallow root structure, we will eliminate them with 1 or 2 treatments, and deep root structure with taproot, by eliminating the above ground portion of the plant is forced into a situation where it must call on those stored starches and sugars and repair its meristematic cells in the growth point between where the roots meet the shoots in order to send out new shoots, and that shrinks its root system. And then coming back in and treating any regrowth at a time before that regrowth has a chance to photosynthesize and regrow the root structure will wear that plant out with repeated applications. In urban situations, we will typically go into an area where there is where there could be, say, 95% weed cover, and within 2 to 3 treatments we can get that back to 5% weed cover, and then it's just a matter of spot treatment. The range of machines starts with machines that deliver 5 litres a minute, and then we jump to 10 litres a minute, which is obviously double, and that's actually our most popular model for using in intensive horticulture, land care, and by contractors, and is used in intensive horticulture on smaller scale, so anything up to about 30 acres. It's also used to a limited extent by some intensive vegetable growers, and for example, 1 to 2 acre of high value crops like garlic. We have a PTO drive model that has just been launched at AgQuip last week. That has an output delivery of around about 30 litres a minute. So it's able to run multiple applicator heads and will be ideal for lowering costs and increasing productivity of our machines into vines, orchards, and any of those intensive horticultural type of crops. It may have some application in broader scale. The largest machine that we have operating at the moment is assisting a tea tree grower in the Tweed to transition to organics, where he'll get a large uplift in the value of the oils that he distills. So that's really in its trial stage at the moment, and we feel we'll have great benefit. And that's one of the photos in the PDF. Intensive vegetable growers like Biopark Farm in the Adelaide Hills, they use the Setu Steam for treatment in between their vegetable crops, and so they're using weed gunnel in combination with the Setu Steam. So they've dramatically reduced their hand weeding costs to control the weeds in between their vegetable rows. They're also using the orchard head to control the weeds in a newly established truffle orchard that they're establishing, where they obviously don't want to have any chemicals disrupting the delicate balance of the fungal associations within the root zone of their truffle orchard. New products that we're bringing to market that are at the prototype stage, which will be on the market, I'd always say within a few weeks, but it never seems to come around that quickly. But we continue to work on it. Is what we call the TrackTech heads. So one of the difficulties in being able to hello, yeah. One of the difficulties that some of our operators have had in being able to effectively control the application of the steam underneath our Rotec heads is the way that they track, and so introducing a wheeled version that will both go in and out of the vines as well as track close to the ground will improve productivity and usability of those heads within vine and intensive horticultural situations. That brings to a conclusion, I guess, the direct users in of our applications, and I really thank you for the opportunity of giving some explanation.
Fantastic. Thanks for that, Jeremy. And we've been able to follow that through on the PDF, so hopefully everyone on the webinar has been able to see some of those images too. Just in the interest of time, I'm going to keep moving and pass over now to Robert Tucker, who's joining us from Western Australia from Agricultural Guided Implement Systems, and it's going to talk to us about the use of radio frequency. And Robert, whereabouts in WA are you joining us from this morning? We're going to go the trifecta of 3 in the field. We've got a picture of you up in the field at the moment.
Yes. Yeah, based in Yornup in Western Australia, just south of Bridgetown. We're just on a small property here and just starting to do some horticultural trials with the system in the next few weeks.
Fantastic. And I understand this has been a bit of tech under evolution and development for quite some time. We were talking earlier in the week, you know, it's almost been over 20 years. Take us through the bit of kit and what it actually does and how it works.
Okay, this system is a precision guidance system for implements. So rather than looking to identify individual plants or weeds within a crop, looking to find the crop row and use that as a reference point for steering the implement. So the system started out actually back in '99 as I was working on a system for spot spraying weeds in broadacre and pasture environments, and we successfully did that. I think they refer to it as green on green these days. And the Danish Ag Department actually wanted to see if we could use that technology for locating the crop row. And that type of started the process of developing the system. At the time, the Danish in Danish agriculture, they were getting atrazine and glyphosate turning up in their water supply at 5 times the allowable limit, so they had to change their method of agriculture. So I spent a few years backwards and forwards to Denmark trying different systems and talking with farmers. And I suppose that's really the key to the success of this system has been liaising and hearing from farmers exactly what they were required to eliminate the use of herbicides in weed control in their crops. So their requirements at that time were a speed of 6 kilometres an hour to be able to get within 2 centimetres of their crop row. The system needed to be low cost and be able to be maintained and even installed by the farmer themselves. And they didn't want any more screens within in the cab of the tractor in terms of setting the system up. So that type of set the performance criteria that we're aiming to achieve with the system. And the main application was high-speed mechanical weeding within the crop itself. And they were doing a lot of work with camera vision systems at that time, but they were found to be limited to about 200 weeds per square metre. Once you got above that, struggled to actually identify the crop row and you started getting inaccuracy. And I was just looking at a document from Germany in 2015. They also were limiting their application to 154 plants per square metre and achieving speeds of 7 to 10 k's an hour. It's interesting, they got an increase in soy crops. Their yield increased by 23% and their sugar beet speed increased yield by 37%. And when we were trialling the system north of here at Mile Up in horticultural crops, we found the same situation. We were getting Well, the farmer noticed his time from seeding to harvest reduced from 13 weeks to 11 and a half, and he was getting a lot better quality in his crop. We tried to put that down to a couple of things. One, we think by high-speed mechanical weeding, not only were you dealing with the weeds and composting the weeds back into the soil, but also breaking the crust on the soil and allowing the oxygen back into the soil. And he noticed that the crops indeed took off for a spurt after the mechanical weeding. And that's reported in this report from Germany as well. And I think some Queensland University did some studies, and that was in one of their reports. So the system we got at the moment, performance criteria, we're getting 10 kilometres an hour. And maybe, Carl, if you could stick that first photo up of the mechanical weeding in, it's a crop of, I think it's broccoli from memory.
Yeah,
on the right-hand side.
That's up at the moment. Yep.
Yep. You can see on the right-hand side there, the crop's been mechanically weeded. That's about 8 kilometres an hour that was done at. And we got very good weed control. The reason for the speed, you need the speed, the accuracy and the repeatability. The speed gives you some sort of movement sideways, which buries the weeds in the crop row itself. So we're currently able to do 10 kilometres an hour with our current system. So with a three-bed weeder, that's 1 hectare in under 10 minutes. If you bring up the next photo, please, Carl, that shows the weeder that we were using.
Yep, that's up now.
Yep. So the beauty of the system, because we're not using GPS or any other form, this is a completely unique system of guidance. We're using radio frequency as the crop locator, is that we've got sub-millimetre accuracy with the system, and it's 100% repeatable. In other words, I think in the last 4 years we've used the system, we've never lost one plant to being hit by the weeder. The system's also met the farmer's requirements. It can be farmer installed and maintained. It's very low cost. We've got it running on the power supply of the vehicle, so you don't need hydraulics to run the actual steering system. And it can operate in any weed density, day or night, and any weather conditions. So it's very universal in its application, and it's a simple system. It's basically auto steer. Once you manually line it up with the crop, you just lower the hydraulics on the tractor, put the implement in, and just drive off. It looks after itself. But in the next, Carl, if you could bring up the video, you can see the system. Maybe if you could let me know when that one's finished.
So it's just starting now.
Okay. So what you're seeing there is you're looking, I think, at the back of the implement. You'll see the implement making adjustments to its position as the tractor's driving. So with that type of system, as you can see, the farmers basically just needs to steer the tractor, and the rest of it's done for him. And once that one's done, Carl, if you could bring up the next one.
Yep. So just
give you an idea.
The second one now for you.
So in this one, you can get an idea of the speed that we're achieving. This is looking down. We estimate it's about 8 kilometres an hour. It might be a little bit quicker. So just while we're going through that, and maybe, Carl, if you could just roll it on to the next one, I'll just talk a little bit more about the application of high-speed mechanical weeding.
No problem.
In terms of the benefits, obviously initial benefit is your cost saving on herbicides, because there's basically eliminating the use of herbicides altogether. That also gives you improvement in soil fertility and all the benefits that go along with that. I was reading some information from the Rodale Institute in the US. In the Midwest in the early 50s, they were recorded soil carbon at 20%. Today it's less than 2%, and they're putting that down to the herbicides and chemicals used. So by eliminating the use of the herbicides, at least at the start, we're already made a step in the right direction towards soil fertility. I've mentioned about the increased growth rate that we've achieved, was achieved using the mechanical weeding, and the increase in yield. One benefit we found is, some some crops are very sensitive to herbicides. We've got some garlic in up. And the farmer we did the trials on, he had lettuce in, and one year we had in his area there was, I think it was either brome grass or ryegrass, I can't remember, but they got a large seed set of that crop, and many farmers turned their lettuce back in, and he was able to take his lettuce to market. He was the only one there, so you can imagine he did quite well with that particular crop. The other application for the system is subsurface drip irrigation, and we've got that set up on the farm here. So because the system's low cost, it can track the subsurface drip irrigation pipe under the ground, and this enables farmers to get all the benefits of subsurface drip irrigation without the high cost of, say, an RTK high precision GPS system. We've reduced our water and fertiliser by about 80 to 90% on average. We've also got some other benefits with the SDI. We've actually improved, there's other benefits with SDI that come with that, improvement in your soil fertility, and because we've been placing some organic fertilisers through the system, which probably normally wouldn't do. And also, of course, we've got the high-speed mechanical weeding that goes with the SDI. Currently, we've got a test site here we've set up, and the idea is to minimum input costs and highest quality and good yields. And we've set up a system where we're using solar pumping for our water. We're using SDI to reduce our fertiliser and water inputs, and we're using the precision guidance system for the mechanical weeding. So our input costs are an absolute minimum, and we're aiming to get the best quality produce with good yields at the same time. So that's basically a bit of an overview of the system and how it is at the moment. We've just finished developing the system. It's been 30 years all up, 20 years of development on the specific system, and we're very confident now, after 4 years of using it in crops, that we could, at the point where we're going to develop, ready for manufacture in the near future.
Fantastic. Thanks for that, Robert, and a really good and detailed look into what you've been working on, and great that we had a couple of videos there to complement some of the facts and figures too. We're running a little bit behind time, so I'm very keen to move on to the Q&A session and throw to the audience to get your questions. So remember to keep those coming in and typing them into the questions box. We've got a couple here, and I might go to Peter Hayes' question first, which was a question for Jeremy, just on some of the key performance criteria we heard from Robert on the radio frequency technology. Can you give us an overview, Jeremy, just on typical working ground speeds, water volumes, and energy sources and costs of that Satu Steam?
Yes, certainly I can. The per 5 litres, it's the diesel consumption is 4 litres per hour. Is that correct? Yeah. That's so it's about 8 litres per hour of diesel consumption per 5 litres. So the bigger the machine, the more the output. We just multiply by the per 5 litres. Now, so that's a 5 litre per minute of water, which equates to 300 litres per hour. And in order to heat that 300 litres per hour by nominally 100 degrees, we'll take that 8 litres of diesel. The fuel required to run the pump and power the generator, again per 5 litres, is going to be about 1 litre of petrol per hour. And our ground speed is typically about 1 kilometre per hour. I'm just going to walk away from the amenities.
No, that's all right. Thanks, Jeremy. What I might do is throw one to both yourself, Jeremy, and also Dave, farmer from Croplands. We had a question come in after both of your presentations saying, is there possibility to combine something like WEEDit with Satusteam for selective saturated steam application? I'm just interested, that crosses across both of your presentations. Dave, I might start with you firstly, just to get your thoughts on that more as a concept.
Yeah, look, I definitely think, the way the future's moving, I think that's definitely something we could all look at, because, once again, WEEDit is looking for the chlorophyll. Once it sees that, whatever system is on the back of it, as long as it can supply fast enough to the system, because the WEEDit solenoid at the nozzle opens in 600th of a millisecond and closes in 300th of a millisecond. So we would need to just make sure, we could always change that as long as we can get the steam there, and depending on the size, always open to new avenues, and the world's the oyster. So let's maybe give it a whirl.
Great. And Jeremy, any follow on from Dave's response there?
I agree. The nozzling would need to be worked out, and the ability for a system whereby we can maintain the temperature and the pressure across the boiler system, which would be more complex than what we currently run at the moment, but very doable. So the brief answer is yes, it can be done.
Yeah, okay. No, great. And we've got a question coming from Michael for yourself, Robert. You mentioned the setting up GPS or RTK is quite costly. A question that's come through is, can you give us an idea of comparative cost of the radio frequency technology compared to a GPS setup?
Yeah, I'm not sure what the costs currently are. I know, in addition to your access fees each year, and that varies, I think, because your RTK's GPS system, to get that type of accuracy, you need a ground-based station on at least 6 satellites to get. Well, you actually won't get the accuracy that this system we've got will give you, and the repeatability is a problem. But I'm thinking that the RTK system, you're looking at least 30,000, maybe more, and then you need implement guidance on top of that. Farmers were telling me that the repeatability is the issue with GPS-based systems. So I'm a member of the International Soil Tillage Research Organisation, and they looked into GPS RTK systems, and they were saying that even if you put all 3 satellite systems into one receiver and had the ground-based station, you still won't get the accuracy and repeatability required for high-speed mechanical weeding. I think Queensland University did some sort of research a number of years ago. They got about 15% crop damage trying it. So I haven't seen anyone doing it, especially in horticulture, as a reliable weeding system. And so even if the cost was down, I don't think the performance is going to be able to provide that which is required for it. So our system we're looking at the moment, the implement steering system, the electronics, antenna, etc., we're looking at under 20,000 for the system at the moment.
Okay, no, great to get a bit more of an idea of some of those numbers. Thanks, Robert. Mark Hinderegger from AHR, I might throw to you in Cowra for a question to the panel. Are you still able to hear us and connect in?
Yep. Yeah, I just unmuted. No, good stuff. I might ask Jeremy, he mentioned there's a range of heads for intensive horticulture. Can you talk about that a little bit better? And just, I guess, some assurance that if you're going into row, there's not collateral damage onto the crops.
Yeah, look, I'd like to be fairly upfront about this in that it hasn't really been the low-hanging fruit that we have focused our development attention on, because of developing technologies like the weed IT and like the mechanical, depending on whether you want to go chemical or non-chemical, those are already at a really efficient stage. And I think that putting Satusteam through already growing vegetables in between those rows, even though we did do it back in 2005 with the University of New England between broccoli and had very favourable results. I think that is never going to be as competitive, and it's also going to be heavier and slower. So I did look into it probably about 8 years ago in Central Valley in California, but to be honest, we would rather stick with the intensive horticulture, and where we will have the most application, I think in vegetable production, we'll be doing prepared vegetable beds before either planting seedlings. Once those vegetable beds have been allowed to fallow and for the weed seed bank to germinate, that's where we'll have a very good effect.
Thanks, Jeremy. And Mark, did you want to put a question to Dave or Robert as well?
I might ask Robert just real quickly if there are any conditions where that radio frequency guidance doesn't work. Is there any?
Yeah, we haven't found any, and we don't know of any. Every test we've done, I've tested the system in the Negev desert in Israel. We've done it in Denmark, here in Western Australia, and in every situation, the system's always provided the same level of performance.
And that's at that sub-millimeter accuracy.
Sub-millimeter accuracy, yeah.
That's excellent. If it's roughly under 20,000, is there, what is the life of this product? Is there anything to wear out? Is there any heads-up maintenance issues or anything like that?
No, look, apart from the antennas that's just above the ground, so there's a possibility there of, we brought it above the ground. It used to sit on the ground before, but we had trouble with rocky ground. We found that in Israel, so that enabled us to address that issue. So there's nothing really there that's consumable or subject to wear. We're still using the same piece of equipment for the last 5 years, and it looks like we just made it. We have a new system developing, which we'll be testing, which will increase the speed up to, we're anticipating 15 kilometres now. I'm hoping to have that field tested next week. So it'll still have the same accuracy at that speed.
Yep. Excellent. I might real quickly ask Dave, that WEEDit can be attached and do weed mapping as you go across paddock, is that right?
Yes, so we released a new WEEDit at AgQuip this year, just last week, and at the present stage, it's not there, but within the next 6 months, it'll be able to map it as you go across the field, and within the next couple of years, be looking at green on green.
Yep.
Fantastic.
Yep,
Thanks,
excellent.
Dave. Mark, I'm just conscious of time. There are a couple of questions that are still outstanding, which we might take offline and follow up with the presenters individually, but thanks very much for your participation as well. Just to wrap up quickly, let's not have the conversation stop here. We'd like to just signpost you to a few resources and other events that we've got coming up. As I mentioned at the start, we've got 5 handouts there on your side bar that can be downloaded and taken away today, covering the global scan and review on weed technology. That's been the focus of this webinar, for a bit of bedtime reading, but also some broader weed management and spray application basics fact sheets. There's also the Croplands WEEDit brochure there from Dave for a bit more information. And also a resource from Jeremy on grapevine management, which has some great comparative costs in terms of initial capital investment and cost per hectare for some of those weed control methods. So do jump online and have a look at our website, soilwealth.com.au. There's a whole host of other things there to jump into and watch, listen, read. And I'd also just encourage you to stay in touch through signing up to the e-newsletter if you do want to keep informed. We've got a monthly bulletin that comes out. And also we're going to ask just a couple of very quick questions at the end of the webinar. If you wouldn't mind filling those out, they help us improve future sessions. But look, thank you very much to our presenters, to Jeremy, to Dave and to Robert. Giving up your time has been really appreciated, and I know I've got a lot out of it, just in terms of your insights over a number of years into some really great technology. So thank you very much for that. Thanks to everyone for joining us, and thanks Mark too for your insights and putting a few questions to the panel. This recording will be up online, so you can watch it again or distribute through your networks. But from us here at Soil Wealth ICP, thanks very much for attending, and we'll see you at the next section. Thanks.